back to our digital electronics series. Today, we're diving into the world of binary addition and exploring a fundamental building block, the half-adder circuit. If you've ever been curious about how computers perform basic arithmetic operations, you're in the right place.
Meet the half-adder, the unsung hero of binary addition. It's a small but mighty circuit that takes two single-bit binary numbers, adds them together, and gives us two essential outputs, sum and carry. Let's break it down. Our half-adder has two inputs, A and B, and two outputs, sum and carry. A and B are the numbers we want to add, and sum is the result's least significant bit, LSB, while carry is the most significant bit, MSB. Now, how does it work? Well, for the sum output, we use a special gate called XOR, which stands for exclusive OR. XOR gives us a 1 in the sum output when only one of the inputs is 1. It's like saying either A or B, but not both. That's the magic of XOR. But what about carry? For carry, we employ another gate, the AND gate. This gate only produces a 1 in the carry output when both A and B are 1. So, it's like saying both A and B must be 1 to have a carryover. When we put it all together, we have our binary addition. Sum tells us the result of adding A and B, and carry lets us know if there's a carryover to the next bit. It's a small but crucial part of the binary math that powers our digital world.